Okay, with this next example, you'll notice it's not much different than the previous problems. However, it is a fraction, so I'll just do 3 parts for this. G of 7, we're going to put a 7 in for this x value right there into the original function. So I'm going to put 7 minus 5 on top, 2 times 7 minus 1. Well, that gives us 2 over 13, and that problem is done. Okay, because that's a simple warm-up one. G of negative 1, so we put a negative 1 in for x. And on top we get negative 6. On the denominator, looks like we get a negative 2 minus 1. So that's going to be negative 6 over negative 3, which comes down to be just a 2 for our reduced solution. And then for the third one, g of a half. Now normally you'd see that written in proper fraction notation, but g of a half is going to be 1/2 minus 5 over 2 times a half minus 1. Well, this is going to be negative 4.5 on the top if you use a calculator. But what I really want to focus on is the denominator. The denominator comes down 2 times a half. 2 times a half is 1. 1 minus 1 is 0. Well, we can't divide by 0, so our answer is undefined. And sometimes you'd write does not exist, but you do not write 0. Okay, the answer to letter C is definitely not 0. Okay, I usually go with the word undefined, but you could say does not exist. I think that's what the textbook uses. So just be careful on that. Example number 4 here, I took this straight out of your textbook, and this goes back to actually review example number 1. So the question here is, does this graph show a function or not? The words in the book say, determine whether the graph is that of a function. And this demonstrates the vertical line test. The rule for vertical line test, which I'm sure you watched in the notes, the vertical line test cannot pass the graph more than once. So if we draw a vertical line on this graph, you notice it crosses in 2 spots. And you have to pretend that you're drawing the line in every place possible. So number 43 is not a function. And again, a little bit more of a description for that is that if we drew a vertical line here, it's going to cross in 2 places. Well, the x value is the same in those 2 places. It's got the same x value at both coordinate points. So it fails the definition for a function. All right, since the x values are the same, that really is just sort of a visual of what the definition is for a function. So the vertical line test is really just a visual representation for the previous definition, what we did back on example number 1. So I'll do one more of those on page 28. So let's do number 46. 46, the graph looks something like this. And again, what you'd want to think about is if we draw a vertical line everywhere on that graph, how many times does it cross? So this one is a function. It represents the graph of a function because these vertical lines only cross one time. Okay, you have to pretend that this keeps curving. It does not get straight as you get closer to the y-axis. But this curve is the graph of a function. Okay, I have 2 more examples here. Example number 5 deals with the domain of a given function. So these are meant to be pretty short questions. This is a recurring type of question in algebra, in college algebra. State the domain of the given function. Now again, if you watched the videos, I'm sure you saw some examples of this. But the domain of this is all real numbers except x cannot equal 5. Because 5 is the value of x which causes division by 0. So the question I would ask in class is, what value of x can we not put into this function? What value of x causes division by 0? Well, we can't put a 5 in the bottom. 5 minus 5 gives us a 0. We can't divide by 0. So therefore, that's our domain restriction. Now that's my short version of how I write the domain, shorthand version. Your textbook and my math lab may ask you to write it like this. They're both correct, as far as I'm concerned. And there's lots of other ways to write the domain, but as long as you can make your thoughts clear, it's usually okay with me. But I know my math lab is pickier than I am. So again, the same thing on this one. What I would ask you is, what value of x can we not place in to this function? And really, you just need to look at the denominator, okay? Because this is just an introduction to it. We'll be doing domain on several different types of functions later. So the domain of this one, the domain of x minus 3 over x minus 2, is everything except negative 2. The only thing we can't put into this function is negative 2. All real numbers except negative 2. And again, you could write that in interval notation, and that's fine as well. Okay, and letter C, I just put that on there just to test you, because a lot of people end up getting something like that wrong in class when I ask it. So for letter C, f of x equals 2/3 x plus 5. Now, x is not a denominator. This is not 2 over 3x. So there's no division by x, where on these previous two problems, you'll notice we had an x in the denominator. We had an x in the denominator. This one, x is not in the denominator. It's 2/3 times x plus 5, okay? So the answer to this is all real numbers. We can put any number in. We can put any number in for x, and it's going to work. We can put 0 in. We can do 0 times 2/3 plus 5. So that one, the answer is just all real numbers. And a final example here, again, I have is right out of the book. It says, state the domain and range of the function whose graph is shown. So I picked this one right out of the textbook on page 29. This is number 67. So the question they're asking you is, state the domain and range if you're given the graph of a function. So the thing to remember is that domain is your acceptable x values, okay? And that's, there's a more formal way of saying it, which I'm sure you can read in the book or watch in those videos, but the range is your acceptable y values. And generally, I'll write this in interval notation. But what you need to do is look at the graph. Okay, this is number 67 on page 29. So our domain is looking at the x-axis. So looking at the x-axis here, the lowest x value graphed is right here, is 0. The highest x value graphed is 5. So our domain goes from 0 to 5. Our range are the y values that are shown on the graph. Our range numbers go along the y-axis, okay? From here all the way up to here, okay? So now our y-axis determines our range. Well, our lowest point graphed is right here. Our y value here, at this point, our y value is 0. So our range goes from 0 up to 3 on this one. Our highest y value is 3. So our range is y-axis. Our domain is x-axis. Okay, 0 to 5 was your domain. 0 to 3 is your range. Okay. Now on this one they had solid dots. and in these at these endpoints, so that's why I used brackets. But if you have empty dots, then you just use then you'd use the parentheses. So just be careful. It goes back to interval notation usually. So that's an important thing to review if you weren't sure about interval notation from the first assignment.